All right. This was our parent function, right, of our quadratic equation. Y equals ax squared plus c gives us our parent parabola, parent function, y equals x squared. Okay, now, let's talk a little bit about this a. If a is positive, so greater than 0, my parabola opens which way? Opens up. If my a is negative, it opens downward. Okay, so that takes care of the positive and negative sign in front of the positive or negative a. Let's talk about the absolute value of a. Okay, the absolute value of a. That's my absolute value symbols. If the absolute value of a is a fraction between 0 and 1, and the way we write that mathematically is 0 and 1, a is between 0 and 1. That means it has to be a fraction between 0 and 1. What happens to my parabola? I'll give you a hint. Gets wider. Fantastic. It's a fraction between 0 and 1. It gets wider. Okay, if my absolute value, again, I would kind of listen to this and put your phones down because it's on your huge test next Tuesday. Your PSATs. Yes, it is. The 10th. Okay, if the absolute value of a is greater than 1, what happens to my parabola? Narrower. Fantastic. Narrower. What happens if a equals 1? What happens if a equals 1? I get my parent function, right? Y equals x squared. So it's normal. Okay, what else do we learn? Oh, we learned a little bit about that c, didn't we? What does that c do? What does the c do? C do. C do. C do. C do. What does the c do? What does the c do? Give me a hint. Look at page 1. What did our c do? That's right, it fricked. It moved it up or down, right? Okay. So, and you learned all that when you did this whole page, right? Let's do number 7, just in case, you skipped one. What's my a here? That's right, -3. How'd you know? Because it's the coefficient of x squared. Okay, if my a is negative, what happens to my parabola? Which way is it open? Downward. Okay, the absolute value of negative 3 equals 3, so it's greater than 1. What happens to my width? If the absolute value is greater than 1, it gets narrower. Fantastic. Okay, where's it going to intersect my y-axis? Yeah, at 2. Okay, if it opens downward, is my vertex a max or a min? It's a max. And where is that vertex going to be? Well, we know it's going to be 2. And my x value on the y-axis is always going to be 0. Okay, remember, that's the axis of symmetry. We haven't gone off of the y-axis yet. Okay, so I know that 0, 2 is my vertex. I need at least 2 more points, actually 1 point because it's symmetric, and then I can sketch my graph. This is where your calculator's come in handy. Right, 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 right. Okay, good. I thought so. Okay, go to your y equals. And we're going to put our quadratic equation in there. Yes. Yep. Okay, it says negative 3x squared. Use the negative key. Here's your negative key. Don't use the minus key. If you use the minus key, you're gonna get an error, and you're gonna come up to me and say, "My calculator is broken. It doesn't work. It's a piece of crap." Well, it's not. Probably because you used the minus key. So use the negative key. Negative 3x squared plus 2 and a graph. Well, I'm going to try and get some whole numbers. I'm going to go to my table, my chart. I'm going to hit second graph, get the table. I know 0, 2 is my vertex. I could just make sure, and it is because my y's start repeating. So I have a couple other points. Negative 1, negative 1. So negative 1, negative 1. And another point, 1, negative 1. So 1, negative 1. And now I can sketch my parabola. So you were supposed to finish page 2. Now, turn to page 3. Way back in Unit 9, you guys learned how to solve radical equations, right? If I have a power of 2, how do I undo the power of 2? Yeah, take the square root of both sides. That radical sign takes out the power of 2, or the square root. I get x, and it's 12, but don't forget, it's either positive 12 times positive 12, or negative 12 times negative 12. That's 2 answers. We use the plus or minus symbol, and we know that we have 2 answers here. Well, you're probably asking me, this is a quadratic equation, which is what we were just graphing, right? Probably asking me, hey, can I make a connection to what that negative and positive 12 is? Well, that negative and positive 12 is where these points are intersecting the x-axis, okay? Now that x-axis has a y value of 0, okay? My x-axis has a y value of 0. Those are the solutions / zeros / x-intercepts slash roots of the equation. I use all four of those terms, so you're going to have to get used to me saying roots, zeros, solutions, x-intercepts. They all mean the same thing. They're solutions to the equation. Okay? So, positive and negative 12 are the solutions to x squared equals 144. That's where it crosses. All of these are parabolas. That's where it crosses the x-axis. What about number 3? How do I solve for a? Well, I have to get the a squared by itself first, so I'm going to divide by 2 first. So the 2's cancel. I get a squared equals 49. Then I take the square root of both sides to get rid of the power of 2. And a equals plus or minus 7. So 7 and negative 7 are the solutions to 2a squared equals 98. What about number 4? How do I get rid of a fractional? Multiply it by the reciprocal. So I'm going to multiply both sides by 3, or 3 over 1. And I get b squared equals 36. Square root both sides. So b equals plus or minus 6. I'll do one more example before I show you how to do this graphically. This is algebraically. So, I read an article about some kind of chemical in Mountain Dew. It makes people go into a coma or something. There's some kind of chemical that makes your brain dead. Makes your brain dead. Yeah, I know. They said even the occasional Mountain Dew will fry your brain. You know? Weird, huh? All right, number 8. I'm going to add 80 to both sides. I get 5q. 5q squared equals 80. Divide both sides by 5. Wonderful. I get q squared equals 16. Square root both sides. I get q equals plus or minus 4. Lovely. So you want to know how to do it graphically? Sure, Mr. D, we're so excited. We want to know how to do it graphically. Yes, yes, please show us. Okay, well, look at number 10. All right, so we're looking for these 2 points. The solutions, the zeros, the roots, the x-intercepts. Remember, this is my x-axis. This is where y equals 0. Okay? What does that look like they should be to you?
Oh.
What do you think? Huh? 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 Anybody? 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 Anyone? 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 Bueller? 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 Negative 2 and 2. Kind of looks like that's our intercepts, right? Well, let's check it out. Because in math, you got to be, perfect. Well, not really, but most of the time. Depends on who your math teacher is, I guess. Boy, that light is reflecting right on my calculator. Okay, go to your y equals. clear it out. We're going to put in our quadratic equation. X squared minus 4.5. We're going to graph. And, I don't know. Looks like it's not exactly there. Well, we know that the y value is 0. So this must be negative 2 comma 0 and 2 comma 0. Let's go to our table and see if we get lucky. Second graph is our table of values. Negative 2. Oh, no, it's negative 0.5. So those are not the zeros / solutions / roots / x-intercepts of our quadratic equation. Anybody know how to get those numbers? Anybody know how to get where it crosses my x-axis? I do, Mr. D. When you did that second trace, when you did the calculations, there was one of those that says 0. So why don't you go to second trace for the calculations, highlight 0, number 2, hit enter, and we can find out exactly where those points are. Well, it's asking me to get a left bound to this 0. So I'm going to get my cursor. I got to go to the left, 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 to the left of that point. Well, I'm to the left of that point. I'm going to hit enter. And it says, well, go ahead and make a right bound to that point. Get to the right of that point. So I'm going to use my arrow key. I'm going to go to the right, 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 right. I'm to the right. I'm going to hit enter. Then it's going to ask me, you want me to guess where that point is? I'm going to say, please tell me where that point is. Hit enter again. And I know that this is it because it's giving me a y value of 0. And we're almost at negative 2. We're at negative 2.12. Negative 2.12. Oh, every single one of them. All babies are ugly. They're hideous. All of it. It doesn't matter. All the way up until the age of, I don't know, 6 or 7, they start getting some decent features. No, he's not. He's ugly. Ugly as sin. Okay, since our axis of symmetry is our y-axis, where x equals 0, what do you think this point's going to be? Yep, it's going to be 2.12. Okay, that happens, now the same number, positive and negative, happen when my axis of symmetry is x equals 0, the y-axis. Yeah, really. I'm serious. What? As long as she doesn't bring that ugly kid with.
Stop bullying my brother.
Nah, it's not old
He's
enough.
so ugly. He's so ugly.
Ugly son. Okay, let's look at number 13 since my axis of symmetry is not the y-axis anymore. Well, it looks like it should be what? My solutions. That's right, negative 4 and 1. Let's check it out. Okay, let's put our quadratic equation in there. X squared plus 3x. He's probably ugly too.
Yeah.
Yep, ugly son. Minus 4. We're going to graph this, and our parabolas are the same. Good for us. Now, I know that the y values are 0 here, right? So I'm going to check to see if negative 4 and 1 are the intercepts or the solutions. I'm going to check my chart. So second graph to get our table. And I'm going to look at negative 4. And lo and behold, it is one of the solutions because y is 0. So it looks like we're lucky here. We don't have to do left bound, right bound. And 1, 0. So we're done. We don't have to do it. Left bound, right bound, enter. See how easy that was?
Yeah.
So now you can do the rest of the story. You could do page, what was that page? So you can do page 4. If you really want to, ooh, somebody's pissed. If you really want to challenge, do 24.
No.
So you can do page 4. You can do page 5. If you want to do the book work, let me know. I'll get you a book. Yeah, to be an astute student. This stuff here, this decimal answers, that's the left bound, right bound thing in your calculator. Okay? Any questions? You have to do this work in class because you need a graphing calculator. You can't take my calculators home, even though some of you have, and not return them yet, which we need for Tuesday, your big test. If you have a calc all day, from 8:30 till 1. Yes, it is. It's all day for me because I got to be with you. We've been talking about it all year. And actually, if you are there